Pre-Calc 12, Chapter 7.6. This time we're going to look at double angle identities. These identities you can come up with on your own if you look at it hard enough. So for instance, cos 2 theta. We just substitute theta in for alpha and beta for the sum identity, and cos alpha cos beta is equivalent to cos squared theta. And similarly, we get minus sine squared theta. And again, you can come up with these two on your own, but sine 2 theta is equal to 2 sine theta cos theta. That's an easy one to remember. And tan 2 theta equals 2 tan theta all over 1 minus tan squared theta. Now, by substituting the Pythagorean identity, we can get some more identities. For the first one, we need minus sine squared theta. We'll move sine squared theta over to the other side and we get minus sine squared theta. We move the 1 over to this side and we get minus 1. So now we have 2 cos squared theta minus 1. Similarly, on this next one, we want to replace cos squared theta, so we'll move the sine squared theta over to the other side. So we have 1 minus sine squared theta, minus another sine squared theta, so we have 1 minus 2 sine squared theta. This one is simply a rearrangement of this one, so we just move the minus 1 over to this side, and we get cos 2 theta, and it should be noted that it's just this as a parameter, and then we just add 1, is equal to 2 cos squared theta. Similarly, we can move the 2 sine squared theta onto this side and cos 2 theta over this side, so we get 1 minus cos 2 theta. The half angle ones are a little bit trickier. We just simply continue from this formula. So we have cos 2 theta plus 1 equals 2 cos squared theta. We bring the 2 over to this side first. So we have cos 2 theta plus 1 over 2 equals cos squared theta. Now we take the square root of both sides, so we get cos theta equals plus or minus square root of cos 2 theta plus 1 over 2. And for this one, we have 2 sine squared theta equals 1 minus cos 2 theta. We divide both sides by 2. And we can't cancel these out. Remember, this one is in the parameter. This one is a constant. So this is multiplying the angle by 2. This is dividing the trig ratio by 2. Now we take the square root of both sides. We get sine theta equals plus or minus square root 1 minus cos 2 theta over 2. Now here are some examples of how to use these identities. 2 sine pi over 4 cos pi over 4. We look up here and we recognize that it's this one. So this is equal to sine 2 theta. This is sine 2 pi over 4. This is sine pi over 2. And that's equal to 1. We have cos squared minus sine squared. So this is cos squared theta minus sine squared theta. So this is cos 2 theta. This is cos 2 times 30 degrees. This is cos 60 degrees. And that's equal to 1/2. And this one's easy to guess. This is tan 2 times 22.5 degrees. So this is tan 45 degrees. And this is a special angle, so you should remember the ratio, which is 1. Okay, we can substitute. This will allow us to calculate the unknown quantities. So find sine 2 alpha and cos 2 alpha if we're given that sine alpha is equal to 3 over 5 in quadrant 2. Remember that cos alpha, this is the unknown, is negative in quadrant 2. Okay, so we have minus the square root of the radius 5 minus the side squared all over 5. So this is minus 4 over 5. So sine 2 alpha is 2 sine alpha cos alpha. That is 2 times 3 over 5, negative 4 over 5. And there's nothing to cancel out, so we have negative 24 over 25. Cos 2 alpha is cos squared alpha minus sine squared alpha. We have minus 4 over 5 squared minus 3 over 5 squared. This is 16 minus 9 over 25, and that's 7 over 25. Next example, find the exact trig ratios for 67.5 degrees. We notice that 67.5 degrees times 2 is 135 degrees. So we need to use the half angle formula on 135 degrees because this is a special angle. 67.5 is not a special angle. So we have positive square root. And if you've forgotten, we need to just go up here. We use the half angle formula. We have sine theta equals plus or minus square root 1 minus cos 2 theta all over 2. 1 minus cos 2 theta, and we have 135 degrees all over 2. This is positive square root 1 minus 1 over root 2 all over 2. And we can simplify this to root 2 plus 1 over 2 root 2. Cosecant of 67.5 degrees is simply the reciprocal. So we have square root 2 root 2 over root 2 plus 1. Since 67.5 degrees is in quadrant 1, sine is positive, cosecant is positive. And in fact, all the angles are positive. The formula says plus or minus, but you have to look at where the angle is and use ATSC. All students take calculus. Okay, so we have square root 1 plus cos 135 degrees all over 2. And we have square root 1 minus 1 over root 2 over 2. And that gives us square root 2 minus 1 over 2 root 2. And secant, 67.5 degrees, is the reciprocal of this. So we have square root 2 root 2 all over root 2 minus 1. Finally, for tangent, we could use the formula here. Or if you prefer, we can just use sine and cosine. So we have square root 2 plus 1 over 2 root 2 divided by square root 2 minus 1 over 2 root 2. And this is simply the square root of root 2 plus 1 over root 2 minus 1. And cotangent 67.5 degrees is the reciprocal. So we have root 2 minus 1 over root 2 plus 1. Last example, We have sine squared x and we have cos 2x. So the best thing to do is substitute for this identity. So we have 3 sine squared x. And the identity that we want needs to have only sine in it. So it's best to substitute this one in. If we substitute with cosine, that's not going to help us. We need to have a single trig ratio. So we have plus 1 minus 2 sine squared x minus 2 equals 0. Now we have sine squared x minus 1. We have the positive 1 minus 2 equals 0. Sine squared x equals 1. So sine x equals plus or minus 1. This means x is pi over 2 and 3 pi over 2. So our answer is x equals pi over 2 plus pi n element of all integers. This repeats every pi, so we don't need two separate answers. We have a single answer with a period of pi. And that completes this lesson.